Good morning. Today we will tell about the defects of crystalline structure about the borders. The concept is here. If the axis of rotation lies in the plane of the boundary, then such a boundary is called inclined. And if the axis of rotation is perpendicular to the plane of the boundary, then the boundary is called the torsion boundary. The boundary is of a mixed type, consists of tilt and torsion elements. Boundaries with misorientation of grains less than 10 degrees are called small angle boundaries. And the boundaries with greater misorientation are high angle boundaries. The small angle boundaries are formed by a dislocation system. They are formed as follows. Lattice of neighboring grains or subgrains are elastically marched, with the exception of the places where edge dislocation are located. The boundary between these grains is a wall constructed from dislocations of the same sign. The distance between dislocations of the wall, d, the Burgers vector of dislocations, and the misorientation angle theta are related by the following relations. The larger misorientation the larger the misorientation angle, the shorter the distance between dislocation in the wall. As at disorientation angles greater than 10 degrees, this dislocation model is unacceptable, since dislocation merge. Therefore, small angled boundaries include integration boundaries with theta not more than 10 degrees. As small well as subgrain boundaries, since the misorientation angle of neighboring subgrains does not exceed 1 degrees. The boundaries of grains ground from different centers during crystallizations and phase transformation in the solid state are usually high angle ones. Despite the fact that the high angle boundaries are the oldest type of defects in the crystalline structure, to date there is still no single theory of high angle boundaries. First, an amorphous interlayer model was created. Then a model was Hargreave and Hill translation lattice. Then an inlet models of Mott, which in effect is the basis of all existing modern theories. According to this theory, the high angle boundary is represented in the form of islands of good conjugation of lattice of two grains surrounded by regions of poor coupling. The number of islands of good conjugation is less, the greater the angle of misorientation of neighboring grains. The main question, what is being discussed today, is what are the phases of arrangements of atoms in the areas of poor and good conjugation. In understanding the concept of high-angle boundary structure, large role is played by so-called special boundaries, which differ from ordinary ones in reduced energy and a special Y or of misorientation of neighboring grains. Recently, description of high-angled boundaries based on these ideas of grain boundaries dislocation has developed quite a lot. Such a large number of theories on the structure of high-angle boundaries are due, first of all, to the complexity of the structure and the mechanism of change properties near the boundary, and most importantly, to necessity of explaining the mechanism of migration of high-angle boundaries. Migration of high-angle boundaries is the most important process that ensures the development of a crystallization and various transformation in solid states. It is obvious that the process of migration of high-angle boundaries is rather intensive. Otherwise, there would be no phase recrystallization. However, there is no general mechanism for the movement of boundaries. All modern theories of border migration are special cases that describe the process well only in this particular case. At the end of our lecture, please look the short film about the boundary of grains and subgrains. Thank you for your attention.